Hello, my name is Ken Small with SSA Architecture in Las Vegas, Nevada. And this is part of a series of videos on the solar install that I did on my house at the end of 2016. It's a 22 panel, about 6,000 watt solar install that was done. Today, this particular video is going to begin the process of the actual construction. So before I told you about how and why it was designed and went through the plans, and now I'm going to talk about the actual construction details and what I did and what was done by others and why. So let's start out with the house. This house was originally built in the mid-1970s by somebody else. The previous owners built two additions onto it before I bought it, and I just constructed an 1,100 square foot addition onto it that concluded about 2 years prior to the start of the solar install. So it's a 4,200 square foot house, not particularly well insulated or well built. I did add some attic insulation and some improved windows, but the basic bones of the building are a house that was designed originally with the idea of swamp coolers in the summertime and not being occupied at all, probably in July and August, or just with the expectation you'd be really uncomfortable in July and August with swamp coolering. Sometime in the early 80s, somebody added refrigerated air and a pool, and then 18 years ago I bought a portable jacuzzi. So with everything combined, our peak summer bills are running about $650 a month for 2 months, and that's with gas, hot water, and electric stove, and a few other things like that. We're a typical family, sometimes in and out during the daytime, but often at work, Monday through Friday, or maybe only just one person there. And So, kind of an average house. We decided that we didn't have enough room to fully get all the electricity that we needed to run the house on because of the orientation of the house. And from that we decided that we would just do a peak shaving system that's capable of having batteries installed later on if we want, and it's also capable of having more solar panels installed that are either mostly facing west or mostly facing east due to the roof orientations on the house. So the first picture is that of the existing garage area of the house. As you can see, there's a palm tree on the right that casts a shadow on it sometimes, and there's also another tree on the left which is relatively low that will sometimes also cast a shadow on it. We hired some experienced roofers who went out to the house and removed all the barrel tile. This is a concrete barrel tile, so it's virtually indestructible. Sure, it's old as the hills, but concrete doesn't really wear out. They will break a few when they're moving them and restacking them and moving them back, so we wouldn't end up with the same number after removing them and replacing them, but we have plenty to do what we want to do. They stripped it down to the substrate, which in the old substrate is a building paper, and that's actually the waterproofing on the roof. Swept it off, removed it all off, looked at the plywood decking that was down there, and our plywood decking was in great shape. They went over it with this blue-green high-tech material. That's the new first layer of waterproofing, and then a 30-year-old warranted asphalt shingle product that's going to be actually hidden when the whole process is done, but that will be 100% of what is waterproofing the roof. So you see there my picture with the ladder going up and the Firebird pulling out of the garage, as they're finishing the shingles, and there's a little bit of the blue underlayment exposed. Then we see the size of our panels. So they're about 3 feet by 6 feet nominally. You can see the dimensions in inches if it matters to you, but these are the larger size panels, and they're a little bit more cumbersome to work with than the other ones, but it really didn't matter. These were what fit optimally in the roof area that we had, so that's what we decided to go with. Like most solar panels, these have a glass face on them and aluminum frame going around the outside. Next, you see me up on the roof. So one of the things that I don't like to trust to others, if there's a chance for me to do it, is the layout work. So I got up on the roof and I marked with chalk, and I used a chalk line where all the panels were going, where the fasteners had to go in, got it all marked out. And then I had a laborer come in, work with me for a day, and we installed this flashing, which we got from Alt E store, and the aluminum angles that come up off the flashing. So you see one there sitting next to one of the barrel tile and my tool bag for scale. It's about 1 foot high and about 6 inches wide, and it has a rubber gasket underneath it. So just using a socket wrench, put it on top of that tile on that last row that was installed. It was a problem trying to get the roofers to coordinate with installing the flashing, so it's just easier to let them install the new roof and then come in behind them and use a pry bar to pry up the recently laid shingles in some cases, and slide the flashing and the gasket underneath the one layer of new shingles and on top of the one below it. I did add some caulk just because I'm kind of a belt and suspenders kind of guy. I don't really know that it does anything or that it's needed, but for 20 bucks worth of caulk, it made me feel better about the process, just to exercise a little extra care, because having a water leak underneath those panels, it'll be a real headache to get them up and to try to figure out what's going on. So I figured it would be better to do that. After we got all those down, then I hired a licensed electrician, and the electrician did a great job of going in and taking care of almost everything else. At one point he stopped and I took over again, but they laid the rack system above the angle. So, you know, electricians are not roofers, so they're more comfortable letting me worry about roof leaks and fastening the roof down, and then them taking it from that point above. The rack system isn't really one trade or the other, either roofing or electrician, but the electricians who've done solar panels before would be comfortable in doing the rack. Again, the rack came as part of all the bits and pieces that we got from the Alt E store, and there you see the rack attached to the angle that I installed. One key to understanding why things are the heights that they are is that we wanted to be able to get the gap between the roof and the asphalt shingles to be filled with the barrel tile. This is because pigeons and other critters could crawl into a gap if it's too big, and if it's too small, then you would see asphalt shingles between the barrel tile and the solar panels. So with the height of steel angle that we got and the rack system that we got, it's almost up as high as it can possibly be to get it all fit together nicely, and you'll see that later on. So the solar panel manufacturer and the optimizer manufacturer both use these snap together fittings, and if you are pretty confident in being your own electrician, I would tell you you could do that yourself. Really, the problem is that if you snap all these things together and it doesn't work, how are you going to get an electrician then to buy into the problem? So we got a really good deal from the electrician to have his people come out and take care of all the electrical stuff and the rack system, so I felt it was worth it. These fasteners do just simply snap together, and they worked great. Next slide, you're seeing one of the optimizers, and the optimizers also shows its snap fittings. And so one pair goes to the solar panel, and then the others go into the chain of, or the string as it's called, of inverters. So we had 2 strings of inverters, and that's just because that's the design that SolarEdge recommended. And so they connect end to each other, and then they also connect to a panel. So for each panel, you see in the next slide the back of the panel, a coil of wire with 2 snap connectors, a male and a female, and those snap connectors to the optimizer. And then the optimizer connects to the next optimizers in the chain, one upstring and one downstring. So here you see that on the roof, and a little bit closer enlarged. So the electricians used some zip ties to tie off all the excess wires so that it isn't laying on the roof, and so that it's not blowing around if the wind gets underneath it. And then they just connect them all in rows. And if you refer back to the previous video, you can see that I numbered them so that there was a relation between the panels and the strings that they're in. That's logical, and that's going to turn out to be important when you see how all this works with the software. The first picture we're looking at is our electricians up on the roof installing the rack system and installing the optimizers. So what we had them do is to pull out to what I'm calling the east side of the roof edge, and then I had already drawn chalk lines on the roof for them, measuring back 1 edge tile and 1 full tile before the solar panel install started. And they started in the lower right hand corner and began installing solar panels, working east to west and bottom to top. That was their choice. As they did that, they collected this little piece of cardboard that you see here with stickers on it. Each one of the optimizers had a little code sticker on it that would identify it to the electronic system that manages the solar array. And so they put a little marker on the cardboard to identify where all the panels were relative to the stickers, and later on I pulled the stickers off that and put them on a drawing and scanned it for a permanent record. As they worked their way across, they did a great job of tightening up all the gaps and making it all fit together really well. I used Eagle Electric from Boulder City, Nevada. They're just south of Las Vegas. It's one of the bedroom cities. And Vern Edmondson was the owner that I worked with there. And he came out and looked at everything with me and went over it all before giving me a very competitive price. And he sent out 2 guys who did the majority of the work, electricians' work on this project. And they both did a great job, and I hope they can do the same for you. One of the reasons why I feel like I got a good deal on this is because I made sure that everything was ready at the job site for the Eagle Electric guys when they arrived. The roof was prepped, it had marks on it where everything went. I went over with them what the layout was and explained why. And then all the bits and pieces, every last little one was there for them to start. And there were a couple of things that Eagle did provide that were unique to this locality, and so they had to get them, but they didn't need them till the second or third day, so they were just able to get in there and knock it out quickly, and that made it efficient for them, and I got equally efficient pricing. And of course, going on top of a brand new roof, they knew that all the substrate was going to be good and there would be no problems with that. So as they went across and did all their install step by step, they interconnected everything as it already showed on the drawings in the 2 strings, and then they brought the wiring down to a panel in the garage. You can see that inverter box, and below it the automatic shutoff box, and then you can see the automatic shutoff box has a wiring exposed there showing how they wired everything up. Just taking a minute to explain how the inverter and the automatic shutoff box and all that worked inside the garage. In this photograph on the right hand side, you see an upper white box. That's the inverter, and then the lower white box is used as a wire interconnect box, but it's also its function is to automatically shut off the system if the grid goes down. Now, I don't know what you think about it, but I think it's kind of dumb to make a solar system shut off when the grid loses power, because that's precisely when you want power from your solar system. But our local building officials have made a decision that that's the way it has to work. And so the theory of why they do that is that if you're pumping power into the grid and there's a utility company worker down the block who's fixing lines that he thinks are off, then you could electrocute him quite easily by pumping power into the grid through your solar system. And we know that there's a way to defeat this, so if the apocalypse comes and there's no more electric utility, we can change the wiring around and shut off our main breaker to the utility and then live off the solar power. But it's not easily done, and it's not the best way for it to work, but it is pretty much the way that all the solar systems are set up, because this is a requirement of the building officials. So it complies with the building regulations. The box itself is used as an interconnect for all the wiring except our local network cable. So I was the one that connected the household network through a Cat6 cable to the inverter so that we could read the inverter's mind, so to speak, but the electricians did all the other wiring. And when you're looking at this, it looks relatively simple, but even though I've done quite a lot of electrical work myself as a do-it-yourselfer, it's something new to me, a little bit complicated, not a real brain teaser, but if you wired it up wrong, you could cook the box and then you'd be out $2,000. So it made sense for me to go ahead and have the electricians do it and not do everything myself. Plus I work full-time and I only have so many hours in my day, so at some point you decide that it was worth my time to get up there and fiddle around with the roofing and the caulking and all that other stuff, but not so much for the electrical work. Something that we haven't talked about on this system, which is both good for do-it-yourselfers and not do-it-yourselfers, is that if it doesn't see the grid, then each optimizer only puts out 1 watt. So that means when you put your meter on the wires, if you see 22 watts, that means all your panels are working. So before you connect to the grid, you already have solid feedback letting you know that your inverters and your solar panels are all operational to an extent. And so that's nice while you're all connecting it up, because as you're going across on the roof connecting one after another, first you have 11 watts and then you have 12, so you know you got your 12th panel connected. So when the grid goes down, you're going to see 12 watts in the system, which obviously would be kind of a bad surprise if you grab the wire, but it's not going to electrocute anybody. The left-hand box is our breaker panel that already existed prior to the installation of the solar system. The primary reason why that breaker panel exists is because I have a electric vehicle and we wanted to put 80 amp charger in the garage, and there wasn't enough capacity in the main circuit breaker panel to provide for that. So we got a little bit bigger breaker box when we installed the EV charger to make sure that there was enough capacity to hook the solar panel up to it later on. Also, you'll note from what I said when we were going through the drawings that this system, the inverter, is substantially under capacity right now. Just a little bit bigger inverter was only a couple $100 more, and so we decided that it would be a good investment to go ahead and get the little bit bigger inverter. I may very well add some panels on the west side over time as prices go down, and if I eventually retire, I expect to be in this house indefinitely, so then we'll be getting better power utilization during the daytime, so we might do that. And we might also add batteries, but right now no batteries and slightly underutilized overall. Then going on to the next slide, you see the exterior there. All the panels are installed, and you can see the asphalt shingles surrounding them. And then on the next slide, the roofers are back, and the roofers went around and installed the barrel tile, which is the same barrel tile that's been on the house forever, since 1970s. It's a color match to all the others, and when I tell you they're solid, they're heavy chunks of concrete. So they're sitting up there, going nowhere, and making the roof look like it always did, and none of the neighbors has had a single negative word to say about it. They've all been quite pleased. If anything, I've had half a dozen people stop and ask how they could do it. So quite favorably received in terms of the looks of it. And then we're looking at the two roofers standing on the ridge there. You can see one of them is holding a piece of flashing. We put in quite a bit of effort to flash around these so that pigeons wouldn't get in there. In Las Vegas, because the weather's so temperate, sometimes we don't even have a freeze throughout the entire winter. We have some nice big fat plump pigeons that are liable to, get in anywhere and make trouble, and we don't really mind them, but we'd rather not have them in our roof. So they flashed it, and then they went around and installed the remainder of the tile. And then just a few details. You can see that some of the tile did have to be cut around the rack system to fit it in there tightly. If you're not worried about pigeons or squirrels or things like that, then you wouldn't necessarily have to do that. But the overall roofing job was pretty affordable, and we thought it best to do the best possible to not have any headaches with it. I'm to the point now where if I put a 30-year roof on a house, I figure I'm going to be gone before anybody has to fix the roof. And not many people are thinking they're going to build something like this and then move away in a few years. And that's definitely the idea here. We're building it and planning to live with it forever, and installed it as though that was the situation. So while the roofers were up on the roof installing the barrel tile and the flashing, back down in the garage we had Eugene. Eugene's with Eagle Electric, Boulder City, and he was connecting the last few things and putting some stickers on there that are recommended by the building code, and doing some programming. So the programming is rather a headache. You have this nice little LCD screen. It's a blue screen with white lettering on it. If you need reading glasses, you're going to need to put them on to see that thing. If you're in your 20s or 30s, no problem, but I was struggling with it. But you can see some good information, how much power it's putting out and things like that by pressing the button. More importantly, he was able to give it enough information to where when I connected that Cat6 wire to the household network, I had to open a port on the household network firewall, and then we were able to go out to the SolarEdge website, and I was actually the one who programmed panel by panel where everything was and what it was, so that we can analyze it, and I'll show you that on my phone in a minute after we get done with the build. So the last thing after the LCD screen is external manual cutoff. So probably required by your building department, no matter where you are. Maybe in some rural areas, if you're not under a current building code, it may not be required, but it's still a good idea. And the idea is, if your house is on fire, you can throw that handle there and shut off the solar. So in my case, it's right next to the main electric panel and the electric meter. So if the fire department were to come, it would shut off both probably, and then we wouldn't have an electrical fire anymore if it was an electrical fire, or if the firemen were in there shooting water, they wouldn't have to worry about getting electrocuted or shocked. So that's important. Our next video that follows this one is going to talk about the online management system that SolarEdge has, and why I selected the system was partly due to that. So I think it'd be a good idea to get my take on it, and it also tells you a little bit about the quality of the solar panels that you bought. So watch our next video. Before you do that, please go down to the bottom here and like this one, and go to smallstudioassociates.com, like us on Yelp, go to Google, like us, things like that. If you have any questions, you can go to our Small Studio Associates website, and there's a place there where you can send me an email, and I'll be happy to answer your questions. If there are enough questions, then we might do another video addressing questions, and there will be a couple more videos that are going to be done in the next few weeks, and then when a year rolls around, I'll come back and do a summary video on how we made out financially on the whole thing. So thanks for watching. My name is Ken Small, architect from Las Vegas, Nevada,